So thank you. I will now turn it over to Olivier. Thank you, guys.
So my talk is about energy measurement of Android things on Raspberry Pi with Arduino, a complicated title for a complicated subject. To resume, it is energy measurement of IoT by IoT, a sort of inception. The goal of this talk is to explain you the energy on IoT. I'm Olivier Philippot, and I am the CTO of Greenspector. Greenspector is a startup, a French startup, as you can hear with my accent. Sorry. And we work on energy efficiency for software developer. We want to make the software more efficient, consume less. It is a big problem because while you need to measure energy, software is eating the world. We heard a lot of that, and it needs energy. This morning on the keynote, Amanda was saying that it was magical, but with IoT and with API, with IT, there is also black magic, because energy, and there is a lot of study about that. Transporting bits now use 50% more energy than the world aviation, so we are a domain which consumes a lot of energy. We do a lot of things, but we consume a lot of things of energy. And if we continue, we will use twice as much. So IT will be a big continent with a big consumption. So we have to change some things and to take into account that. And if you don't care about the Earth, I think the user sees this problem, because mobility is everywhere. So user can see the decreasing of autonomy. You can feel it when you plug your smartphone every evening and more. And with IoT, it will be the same, because hardware is supposed to have autonomy of several years, but it is not the truth. And I think if, as a user, on your home you have 100 of devices, and you must change the battery every year of about 100 of device, you will not be agree. You will feel like a slave of the IT, and not the IT for the human. So, yes, there is something to change. And other domains have changed, have such a problem, automotive. And before, there were technical counter like RPM, kilometers, and they changed to more efficient counter, and with gallon per kilometer or liter by kilometer, you can see if you accelerate with your car, you see that you use a lot of energy. So you can change your way to drive. How we measure energy in IoT and IT in general? We have profiling tools, we have CPU, we have performance tools. So we don't measure efficiency. We have no tools, and we don't use a tool to measure energy. So it's not so true, because on your smartphone, you have a little icon with a battery. It is the first step to energy measurement. It is a percentage of battery, and you have a first measure. And how this measure is done, in Android, for example, you see an example of a Nexus 6 specification. There is electronic component which is a column counter, which permit to have the energy. And every smartphone has such electronics. And since Android 5, you have an API, and you can get the energy. So you can integrate this energy in your software and your test. That's the work of Greenspector, for example. And in IoT, a classical architecture, energy is everywhere. So in the smartphone we can measure, but in hardware like things, there is no such counter. You can measure it. In the gateway also, which will permit to to make the object discuss between us and to add a layer of intelligence, you will have no energy information. So the aim of the talk is to work on the gateway and to provide some clues to have energy. The use case is to send the weather information by text to user. Really a simple test case, and we use Raspberry Pi, which is a awesome platform to do project. On the OS, a newcomer, which is Android Things, and it's really great for this operating system. For the weather, we have a Premature, which is a weather station with pressure information, temperature, and you can do project with some dollars. It's really great. And we will use the Cisco Tropo API to send SMS. So it is a use case. Android Things, if you use to develop in Android, you will be able to develop in Android Things because it is the same tool. See it, Android Studio, it is the same layer. You have just one thing more, which is the Things support library. So if you use to develop in Android, in 1 hour you can have a project on IoT on Raspberry because you have images available. So how to measure? What we do to measure energy? We use the Arduino to manage energy. Simple. And to measure energy, it is really simple. We use Shunt, and it is the same architecture as in your smartphone. Shunt, it is a little resistor when you pass where current pass, and we cut the cable which powers the Raspberry. And with the Shunt, you can buy on Adafruit website, the same thing, the same site where you buy Arduino. It is $10. So the Shunt is really simple. After, here the final infrastructure. So you have the Raspberry, which is linked to the Ethernet. You have a power cable which is cut and which passes by the Shunt, and the Arduino manage the measure, and the measure is sent to the data, to the computer. So it is the inception. On Arduino, it is really simple. You take the chain voltage, the current, and if you remember of a ohm law, you can have the power. So we send the power to the computer. On the Raspberry Pi and Android Things, it is the same thing. Really, if you use to develop Android, you create a simple application, and in some lines, we send the message and the information to the web service with a number, and we do that every second. So I don't pass. I pass to the result, and the result is here. So in idle, you see, idle is when your Raspberry Pi with Android Studio with Android Things don't do nothing. You have a constant power consumption. So okay. After, when we send the SMS every 1 second with some information, we have some peak. So here we can say we have nothing to say, and we must do projection. And for IoT, if you want autonomous IoT, yes, we take a battery, which is a 10,000 battery, milliampere hours. To understand, smartphones are 3,000 and 4,000 ampere hours. Here, the reference is idle. So the idle is you leave the Raspberry, do nothing. First finding is that the autonomy is 37 hours. So if we want a big autonomy, with the first finding is that with the Raspberry Pi and Android things, you have just 2 days of autonomy. You will have to change the battery every 2 days or to charge. So Raspberry Pi is not, it's good for prototyping, but for real use case with a big autonomy, it's not the good thing. You have to do some better electronics, or you have to plug your Raspberry Pi to the grid. So it is the first thing to say. After, you see that when we run the Android application, you have a decrease of 2 hours. So okay. And we send the SMS every 1 second, you have 20 minutes. So Cisco API is not consume not a lot of energy. I think I will be able to come back to the DevNet too, because if it was bad, I think. So yes, there is no energy. What we do is after we plug the weather station, because before there was no weather station, and we see the information of temperature, which is viewed on the alphanumeric display and sent to the SMS. So there is a decrease of 8 hours. So we see that it's a big decrease of autonomy, and for the moment you can say and ask, is it the hardware or the software fault? Because we need to say, okay, software, no. Software is virtual. There is 0, 1, 0, 1, and it is hardware which consumes. I do a parenthesis about a use case we have. We measure the Android Google system UI, which is the interface of Google. You have the status bar when you go to the notification, the recent app, also all the icon. And we see it is the same thing. The reference is the energy when you keep the smartphone on with the screen. So 100 microampere by second. When you show the recent app, you have an increase of energy, and when you show hide the status bar, the energy is multiplied by 3. So it is a big energy consumption. It is the same thing than a video. So a video is a long during of playing, but just 1 second for the status bar, but just for viewing some icons. So it's not a good thing. And why we have such a consumption? It is not the hardware, because the hardware is here. The hardware consumes with the screen 100 microampere hours. So it is the same here. And it is a software, because all the CPU, all the data, there is a software which consumes. And to explain what happened in system UI, you have Android system with the software event, the hardware events with management. On your software here, and on system UI, you listen all these events. So when the user touches the screen, you open all the listener, you listen all the battery events, the Wi-Fi event, a lot of system, and all is put. All is put on the algorithm, and we put on all the graphics. So there is a lot of redraw on the interface, and that's why it explains the high energy consumption. The user don't see anything because you have 8 CPU core on the smartphone, but there is energy consumption. What we see that here is it is the event. The events are not managed. We said we don't need to program with pooling, but we need to go to event programming. So we go to event programming everywhere, but there is a drawback, and it is a drawback. So events are like butterfly effect, and it is the same thing on IoT. There will be a lot of events which will be sent to the data center, to other objects, and if we don't manage the event, we will have some drawback effect. And it is the same thing for our use case. We, on our Raspberry Pi with the Rainbow at weather station, the temperature is sent every millisecond. So every millisecond we set to the display to change. And we set also to the SMS to be sent. So there is a lot of event. What we do, we just put a loop, a counter, and we manage one event every 20 events. So 19 events were not managed, not sent to the alphanumeric display, not sent to the network, and we increase the autonomy by 40 minutes. So it is a first evolution, a first improvement, but we can go further on the optimization. It shows that the hardware, yes, is not really important. It is not consuming. So after you can continue to say, no, it is the hardware. And you go to premature optimization because a lot of developers said, okay, I don't want to optimize. It is a definition of Donald Knuth on the 17th, and so all the developers have on the brain premature optimization is the root of all evil. So, okay, but it was 40 years ago, and now we are not the same hardware. We have not the same layer of software. We have a lot of layer. So there is no premature optimization, and we saw that on all software project we have. When you begin to optimize, you have gain. You can reduce energy consumption. You can avoid obsolescence of hardware. You can put more feature on your software. So it is really important. And the event, with the event, we see that. So as a conclusion, so IoT energy consumption will bloat. I think that hardware manufacturer will improve the hardware. It is the same thing on the computer, but software is going faster, slower. So software is really not following the improvement of hardware. And it is not code, it is event, it is data. Data we send, data we manage, so we need to think about that. What we try to push also is the measure, the energy measurement, not only the performance, but the energy. Because if I ask on the room who measure energy on this software or hardware, I think nobody. And so we need to measure, because if we don't measure energy, the user will consume a lot of energy. And efficient IoT is good for the Earth because energy reduction, but also for the user because you will have a better experience by not plugging your IoT to charge it or to change the battery. So it will be a great thing. So you can follow me or keep in touch with the website. Thank you.